All right, so we're going to go through and review some important problems for your upcoming exam, number 3 for trigonometry. I've outlined the main things that you want to go over, and these are some good examples for you to look at. All right, so we're going to go down to this bottom example here, and this is where we were talking about the double angle identities. All right, so the first thing on this problem is we're going to find the value of sine 2x, cosine 2x, and tan 2x given this information. So to start with, I'm going to begin here. So you're given that the tangent of angle x is negative 2/5, and you're given that you're in quadrant 2. So the first thing, if you're in quadrant 2, you know x is a negative number. You know y is a positive number, and r, of course, is always positive. All right, so the definition of the tangent is y over x. So that automatically gives us a couple of things here. So let's see, x is going to have to be negative 5, and then the y is going to have to be positive 2. So now we can find r easily enough. We know r squared is x squared plus y squared. So by the Pythagorean relation, we just plug this in, work this out. Okay, so we're going to do that. We have r squared, that looks like 25 plus 4. So r squared is equal to 29. And then I can square root both sides. So I end up with r is plus minus square root of 29. However, r is positive, so we end up getting that. So that's the key to the problem, is figuring out these three things. You got to know x, y, and r. And once you do, you can use the identities to figure out the rest of this. Okay? So now we'll move on to the second thing. We're going to go ahead and find the sine of 2x, which should be a fairly simple thing to do. The identity, the double angle identity for sine 2x is 2 sine of x times cosine of x. Okay. So I just plug in. We know the sine is y over r. So we just take 2 over the square root of 29. And then we know the cosine is x over r. So that would be negative 5 over the square root of 29. Then we just need to multiply this out, and then we got it. Okay, so I'm going to put the 2 over 1. Multiply the numerator straight across. 2 times 2 is 4, times negative 5 would be negative 20. You have the square root of 29 squared, so that just gives negative 20 over 29. Okay, so that would be the exact answer to what the sine of 2x is then. Okay, all right. Now I'll move on and I'll do the third thing. And the third thing here is the cosine of 2x. And remember, you have 3 forms of this identity. So you have cosine of 2x is equal to cosine squared x minus sine squared x. That's also the same as 2 cosine squared x minus 1. And that's also equal to 1 minus 2 sine squared x. So it's really up to you which identity that you want to use here. So just take your pick. It doesn't really make that much difference. So I'll just go with the first one, I guess. So we're going to work out cosine squared x minus sine squared x. All right, so it should be a fairly simple thing to do. The cosine is x over r. So go back to your x, y, r. That would be negative 5 over the square root of 29. The sine is y over r, so that would be 2 over the square root of 29. Okay, work these out. If you square negative 5, you get positive 25. You square the radical 29, that just gives 29. And then the next one, if you, whoops, forgot to write my square. 2 squared is 4. And then the square root of 29 squared is 29. Okay, then you can put that together. Now you got a common denominator already, so you would get 21 over 29 would then be the answer to that problem. Okay, that's it. All right, now that leaves us with the fourth thing to do, would be the tangent of 2x. Now you have a couple of choices. We have the tangent double angle identity, you can either do that. There's two ways to do this. So the tangent identity, double angle, goes 2 tangent x over 1 minus tangent squared x, like this. So you could do this problem one of two ways. All right, so I'm going to go ahead and do it using the identity first of all here. So I'm going to put this in here and go over this. Okay, so let's go ahead and do this identity, but I'll show you a much easier way to do this problem in just a minute. Okay, so tangent of 2x, we're just going to use this identity. So it's 2 times the tangent of x. The tangent's y over x. Well, see, you're already given that as negative 2/5. So you're given that. And then you could just do 1 minus tangent squared x. Again, the tangent of x was given as negative 2/5. So square that like that. So then you could just work out this arithmetic. So you would have, basically, you would have, the numerator would be negative 4/5 when you multiply that across. You would have 1 minus positive 4 over 25 when you square that. Okay, now what I would do is, this is a complex fraction, so if I want to get rid of both a 5 and a 25, it works nicely to multiply the numerator by 25 and the denominator by 25. Okay, and when you do that, you would just have, the numerator would be negative 4/5 times 25 over 1. Denominator, you distribute, that would be 25 times 1 is 25, and then minus 4/25 times 25. You can do some of this in your head if you want to. So what you would have here is, notice the numerator, 25 divided by 5 is 5. So you would end up with negative 20 in that numerator. And then the denominator, you would have 25 minus 4, because the 25s divide out to give 1. So it looks like the answer to the problem is negative 20 over 21. Okay, now I want you to notice something here. Whoops, if you look at the answers to the sine and cosine, see how they have a negative 20 and 21 in them? I wonder where that came from. Well, here's the easy way to do this problem. The tangent of 2x is just equal to the sine of 2x over cosine of 2x by the ratio identity that we've learned. So the sine of 2x we found to be negative 20 over 29. The cosine we found to be 21 over 29. So this is really just a division problem. So it's really negative 20 over 29 divided by 21 over 29. So you just get negative 20 over 29 times the reciprocal, with that canceling, and you got your answer. Okay, so it's a little bit easier to do the problem that way. So you could actually get the answer to that either way. Okay? So that's primarily an exercise in working out the appropriate identity. You're given enough information to pinpoint and find exactly what x, y, and r are, which we've seen over and over again in this class. Okay, let's go to the next thing here, and we'll begin to look at this. Okay, so I pulled up a unit circle here. You're going to use double angle identities to find these. Now, you're not just going directly to the unit circle. I mean, you could do that to check your answer, but this is an exercise wanting you to use double angle identities on this, see, okay? So first of all, if we just cut this in half and divide that by 2, we get 240 degrees. So we're going to work this out like this. The sine of 480 degrees, we're going to write that as the sine of 2 times 240 degrees. Okay? And then the double angle identity, the sine of 2 theta is just 2 sine theta cosine theta. So we're going to apply that identity, and the key thing to know on here is, theta is the 240 now. It's not the 480. So what you would have is, you would have 2 times the sine of 240 degrees times the cosine of 240 degrees. Okay? So now what we would have is, you would have 2 times the sine of 240? Well, you just go to your unit circle now. So if you locate 240 degrees, the sine is the y value. So that would just be negative square root of 3 over 2. So that's your y value. And then the cosine would be the x value. Okay, so just look up your x value. And that would be negative 1/2. Okay, so now what we would do is just multiply straight across. Now one thing that you might see on here is, I see, is 2 divided by 2 is 1, so that cancels out. So you're left with, it looks like positive square root of 3 over 2 is your answer. Okay, and you got that. All right, so you could go to 480 also, and if you wanted to verify the answer of this problem, well, 480 minus 360, if you do, that's 120 degrees. So if you go to 120 and look up the sine, look at that, it's square root of 3 over 2. Okay, obviously that's the easiest way to do the problem, but the point of this is to gain some experience and comfort with working with a double angle identity, okay, like that, okay? You could even, on a graphing calculator, easily check the answer to this problem. So if you're in degree mode, you would have to be in degree mode since we're working with degrees. So if you went through and just did the original problem, sine of 480, like this, and then you took your answer, which is square root of 3 over 2. Don't put it in that way. Square root of 3 over 2, like this. Then it should check and verify your answer, which is easy, okay? All right. So let's go to the next thing here. So what you could do on this, there's a couple of ways to go about doing this particular problem now. This one I think I was going to maybe change that problem because 3 pi over 4 is 135 degrees. This is probably not a real good problem to look at with a double angle identity because you wouldn't be able to pinpoint and get an exact answer that way without going into another identity to do that. So I think I was going to change that. So I'm going to pause here just for a second.